So continuing from yesterday, light bulb questions are a good test of student understanding of Kirchhoff's laws. In fact, Kent, there is going to be, you're using principles of physics, right to explain question. I guarantee it's going to be a light bulb question. And what I'm going to ask you about is the brightness of a bulb. When I talk about a light bulb's brightness, am I talking about its voltage, its current, its resistance, or its power? Fahim, what determines a light bulb's brightness? There's a reason I'm asking you. Watts. Okay? So the brightness of a light bulb is related to its power use. More wattage, brighter bulb, smaller wattage, dimmer bulb. My mom says we won't go there. Example 9 says the bulbs below are identical, same R. Which bulb is brighter? You can do these by making up numbers, and if it's a really complicated one, I might be tempted to say, well, if they're the same resistance, I'll let each one be 5 ohms and I'll solve this. But I think we can do this one just using Kirchhoff's laws. We're also going to use the idea that V equals I times R and that power equals V times I. First thing I notice is they did tell me they have the same resistance. Yes? Okay. Let's label downhill. Downhill, 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 downhill. Is that okay, Marcus? Okay. Marcus, let's do that. First of all, if I was trying to solve this, I would look for anywhere with currents. Do you see currents, amps anywhere? Yeah, I would start there. Let's try our ski trick. I'm going to argue there's 2 ski runs. There's this inner one, and there is the outer one. So, Marcus, let's ski the inner one, you and I. How many volts do we gain? Whee! Did that get us to the bottom? How many volts did I lose going through here? How many volts do I lose going through bulb B? Same argument. So I'm going to make a note. They each have the same voltage loss. Well, Marcus, is there a version, what are we talking about? We're talking about brightness here. Is there a version of brightness that has an R and a V in it? Is there a version of power that has an R and a V in it? Look at your formulas. Oh, you're right. It can be squared over R. Yeah, okay. Well, if V is the same and R is the same, P must be the same. Now, I lost a few of you there, so let's go even more basic. Marcus, do they have the same R? Do they have the same V? Well, if V equals I times R, if V and R are the same, you know what else is the same? And I could also have done that by saying, you know what, they're identical resistors, they're going to split the current in half. We talked about that yesterday. Well, if you have the same VI, you're going to have the same power. Therefore, same power equals VI. These will be the same brightness if the resistors are identical because they're getting the same current and they're using the same volt. Won't all bulbs be the same brightness if their resistances are identical? No, not if we get to more complicated circuits, no. What about here? Well, let's see if we can use a similar kind of a concept here, Hannah. Let's label downhill. They told me each bulb is the same, so Hannah, I'm going to say same R. Oh, are these bulbs connected in series? Are there any junctions between them at all, Hannah? Then you know what? Not only do they have the same R, they have the same current because there's nowhere else for the skiers to go. Well, if you have the same R and you have the same I, you know what else you have that's the same? And now you could do one of 2 things. You could go power equals I squared R, and you could say same power. Or if you just want to keep using power equals V times I, if R is the same and I is the same, they have the same voltage. Each one of these, I'm telling you, Kate, is using 5 volts. There's your 10. And so then you could say, therefore, same power equals VI. But you could have even gone straight to I squared R once you knew that R and I were the same power, same brightness. So that was what I didn't quite get to last day. Pause. Talk today about series and parallel resistors. Record lesson. I am. Series and parallel circuits. Two or more resistors are connected in a row with no junctions between them. So of these two examples, which one has resistors in simple series, the top circuit or the bottom circuit? Don't overcomplicate it. This is series. Again, two resistors are in series if there are no junctions between them. Example 2 says, analyze the following circuit. A says, fill in the voltage drops in each resistor. And then B says, can you find a mathematically equivalent resistance if there was only one resistor instead of three that gave you the same current? Well, let's label downhill. I always start with trying to find total current. Victor, did they tell me how many amps are leaving this battery? How many amps right here? How many amps right here? How many amps right here? Did they tell me how many amps are leaving the battery? Yep. Oh, not only that, Victor. How many amps right here? How many amps right here? How many amps right here? You know what? Let's fill those in. That's Kirchhoff's current law. And I like how Marcus reached for his calculator because he went knock, knock. I know two things. Victor, what's the voltage that I lose in that top resistor, that 3 ohm resistor? Because I know two things. So if you haven't yet on this page written V equals I times R, you probably should. It's also on your formula sheet. So do I know the current, Victor, my friend, in that top resistor? Yeah. Do I know the resistance? Yep. You might be able to do it in your head because it is 4 times 3. Yes. How many volts did I start with from the chairlift? How many have I just lost? You just told me. Leaving 36. Okay. How many volts will I lose going through this right here? I times R. 4 times 4. There you go. What about the bottom? I can do the bottom in two ways. I could go 4 times 5, which is, or I could have gone, it's going to be 48 minus 12 minus 16. That leaves 20. So the fact that I got the same answer both ways tells me I probably did this correct. 20 volts. Okay. So find the voltage drops in each resistor. Did we accomplish part A, Victor? What does B say? It says, can you find a mathematically equivalent resistance? So what was the battery? It was 48, yes? Here's my question. Suppose you replace those 3 resistors with one uber resistor. Oh, and you still wanted 4 amps. Well, Eric, how many volts do I gain from this chairlift? How many volts must I lose going through this resistor if this got me back to here? How many ohms is that equivalent resistor? So again, all of you should be going to V equals I times R, get the R by itself. Don't be looking at me like blankly. This is Ohm's law. What? So you're telling me, and you're correct, that that top circuit is mathematically equivalent to one 12 ohm resistor. Yes? How big is the top resistor? The side resistor? The bottom resistor? Any thoughts on how you can get a 12 from those? The rule for resistors in series, if you want to combine them, is as simple as it gets. You add them together. If you're adding series resistors and they want you to find the total resistance, it's just going to be the first resistor plus the second resistor plus the third resistor plus the fourth, but however many are in series. Now, if there's any junctions between them, stop. You can't go any further. But if there's no junctions between them, add them up. So example 3 says, select the best answer for the voltage drop across the 20 ohm resistor. The 20 ohm resistor, do I lose 100 volts, more than 50, or less than 50? I'm going to just solve this. Here's what I mean. First thing I'm going to do is label downhill. If I was solving this, Nicole, the first thing that I would look for is the total current leaving the battery. Did they tell me the total current leaving the battery? In fact, do you see amps anywhere? I would start there. My next would be, is there anywhere with two things? Do any of the resistors have two things on them? Two pieces of information? Oh, then I would try skiing. Problem. I know these two together are going to add to 100, but I don't know if this is 3 and 97 or if this is 98 and 2. Oof. As my final resort, I will try rewriting this circuit as its mathematical equivalent. Now, what's the mathematical equivalent? There's still a 100-volt battery. But if I wanted to replace that 5 and that 20 with one resistor, well, first of all, Nicole, are they in series with each other? Then what can I replace a 5 and a 20 in series with? Yeah. That, Kenta, is the mathematical equivalent. Oh, and not only that, Nicole, I can tell you how many volts that 25 has to lose. How many volts does that 25 have to lose? Yep. I know two things. I can now tell you the current flowing through this. In fact, you know what? Better yet, I can tell you the total current. The total current is the total voltage divided by the total resistance. And once you have the total current, the question's going to fall apart. What's the total voltage in this circuit from the battery, Nicole? 48 is the total voltage. What's the total resistance in this circuit? Sorry, 48 is not the, sorry, 100. I'm doing the wrong one here. 100 is your total voltage. What's the total resistance of this circuit? And once you've done that in your head, what's the total current? 4 amps. Which means not only is there 4 amps leaving the battery, but I'm telling you, this question is going to fall apart. Because how many amps are going through the 5 ohm resistor? How many amps are going through the 20 ohm resistor? How many volts do I lose in the 20 ohm resistor exactly as a number? It's going to be 20 times 4. What's the correct answer, A, B, or C? And for my proof, oh, I would probably write the 80 volt there. You don't always have to rewrite a circuit as its mathematically simplest equivalent, but at last resort, that'll get you there. So series, nice and easy, add them up. Example 4 says, find total resistance and current, and then find the current through and the voltage drop across each resistor. So it wants me to find R total. My abbrev for R total is R with a capital T subscript. Okay, Brendan, are these 3 resistors in series or in parallel? So you know what? I can just go 15 plus 5 plus 5. In fact, you might even be able to do that in your head. What's R total? What's I total? I total is going to be V total over R total. What's the total voltage from this battery? What's the total resistance? Hey, Mr. Dueck, the answer is always 4. No, I just made up 2 similar examples is all. 4 amps. So they wanted me to find R total. Did I find R total? I'll put a box around it. They want me to find I total. Did I find I total? I'll put a box around it. What else did they want me to do? Read the instructions. What else did they want me to do? Already did that. I got, look, I just said R total, I total. What else did they want me to do? Read after the comma. You're way overcomplicating this. What? There's something before that. Then find the, find the, keep reading. Okay, find the current through and the voltage drop across each resistor. You know where we're going now? Okay, okay. Well, how many amps are leaving the battery? 100 amps are leaving the battery? That's a bad guess. How many amps are leaving the battery? How many amps in the 15 ohm resistor then? How many amps in the 5 ohm resistor then? How many amps in the bottom resistor? Knock, knock. I know two things. How many volts are we using in that top resistor? I times R, 60, yes? How many volts in the right-hand resistor? And then I have a choice. I could either use the ski method. I could go, Brandon, 100 minus 60 minus 20 leaves 20. Or I could go I times R and also get 20. I would probably do both because if I get the same answer both ways, I'm probably right. You okay with that? Okay. Not overcomplicating things anymore. You still will. I know. It's you. What about, so that's series. Nice and easy. Aryan, add them up. Parallel is tougher. I want all of you to get your calculators out because I'm going to show you a specific way to do this that may involve using a previously neglected button on your calculator. A parallel circuit is a circuit where resistors start and end at the same voltage, same height. Which of these two are in simple parallel? Top one or bottom one, Taya? Which of these two are in simple parallel? Top one or bottom one, Taya? Here's how you know. Let's suppose we're sitting here, I'm just making up numbers, at 12 volts. How high are we right here? 12 volts. How high are we right here? 12 volts. How high are we right here? 12 volts. Are we all meeting up here? We would go through the same voltage drop. They're in parallel. So you all can just circle that one. Caught you yawning, Alice. I'm coming at you. How do we calculate total parallel resistance? You can't. Well, what you can find is its reciprocal. What you can find is 1 over R total. And that's going to be 1 over the first parallel one, plus 1 over the second parallel one, plus 1 over the third parallel one. Now that gives you the reciprocal of the answer. Then to find R total, take reciprocal of, and I'm going to say your answer button. So you have to recognize that resistors are in parallel. Did I give you both of these rules on your formula sheet? I can't remember. I gave you the series and the parallel one? Wow, I'm mellowing. I used to not. All of you on your calculator, you have, well, you know what? Let's come back to that. Example 6. Fahim, you're yawning. What does example 6 want me to find? Stop. Those 3 resistors, are they in series? No. You know what they are in? Parallel. So my abbrev for R parallel is R, I use the parallel sign. 1 over R parallel is what we're going to find. Aryan, that's going to be 1 over 10 plus 1 over 5 plus 1 over 20. Write that. But then don't go to your calculator yet. Once you've written that down, get your calculator out. All of you have a reciprocal button. It's a little x to the negative 1 usually, although it might be a 1 over x button. All of you right now, I'm going to pause the video, you need to find that button on your calculator. fastest way to do these with the least amount of typing. You don't type 1 divided by 10. That's a waste of time. All of you type 10 and then hit your reciprocal button. Should say a little -1, or some of you might put it into a fraction. Plus 4 reciprocal button, plus 20 reciprocal button, and then hit equals. That's not the answer. That's the reciprocal of the answer. So just hit your reciprocal button again. It should automatically put the answer in there and hit equals. The equivalent resistor of those is 2.5 ohms. That's the fastest way to type it. So, by the way, don't put equals. I'm being fussy. If you put equals, you're telling me 2.5 ohms is 1 over R parallel. What I always do is I write that out, and then I just draw an arrow. R parallel is 2.5 ohms. In other words, if I rewrote this circuit, it's the same as a single resistor. That is the mathematical equivalent of that top one. What's the total resistance of this circuit? 0.5 ohms. What's the first thing they wanted me to find? What's the first thing they wanted me to find? Done. What's the next thing they wanted me to find, Fahim? I total equals V total over R total. 36 divided by 2.5. Fahim, what's the total current running through this circuit? I have no idea what you said. What? Units? Amps. Put a box around there, because in fact, I really should have put a box around this, because this is something they want me to find as well. Okay. What's the next thing they wanted me to find? Okay. How many amps are leaving right here, Fahim? Oh, label downhill. Should have done that first, right? Eventually, you'll get good enough that you might be able to just do the downhill thing in your head. But in our notes, let's get that habit. How many amps leaving the battery? Do I know how many amps went down the 10? No. Ski. This has 3 ski runs. This one, that one, and that one. Fahim, let's do the smallest ski, the narrow ski, this one first. How many volts do I gain? Whee! Did going down the 10 ohm resistor get me down to the bottom? How many volts do I lose? Write that down. Knock, knock. I know 2 things. How many amps do I use up in that resistor? How many amps went through that one? How'd you get that? You're right. Okay. Ooh, how many volts do I lose going through the 4 ohm resistor? Whee! Yeah, same skiing trick. So let's write that down. How many amps do I lose going through that resistor? Yeah? 9? Yeah? 9? Yeah? Yeah, 9. And for the last one, I have a choice. How many amps was I starting with? I could go 14.4 minus 3.6 minus 9, because I only have 1.8 amps left over. But I could also say, hey, this is 30, Mr. Dueck, 36 volts. When you go 36 divided by 20, please tell me, do you get 1.8 amps? Woohoo! Could I now also ask you to find the power loss in each resistor, V times I, or I squared R, or V squared over R, knock yourself out. Okay. So to combine parallel resistors, you don't. You combine 1 over R parallel, which is 1 over the first one, plus 1 over the second one, and then take the reciprocal of the answer. Example 7 says find I total, R total, and then find V, I, and P for all resistors. Gotta be honest. First of all, I'm just going to scribble out the and P because it's going to be too crowded. I added that, and then I thought it's too much writing. Once you have all 3, you can find the power. If they didn't ask me to find R total and I total, I could just do this because how many volts am I going to use in this 10 ohm resistor? Ski. How many volts will that 10 ohm resistor use up? And now I can find the current. How many volts through here? Also, and how many volts here? Also, if they hadn't said find R total and I total, I would not rewrite this. But since they said find R total, okay. 1 over R total is going to be 1 over 10 plus 1 over 15 plus 1 over 20 on your calculator. I get 4.6153. These are tough to make work out evenly, so don't expect reciprocal resistors, parallel resistors to work out nicely. I would probably store this on my calculator. Is it 4.615384? I'm going to write 4.62, but I might carry the extra sig figs somewhere if I need to. Resistance units. Okay. Okay, what's the next thing they wanted me to find? Oh, that's V total over R total. 60 over, I'm just going to go answer, but 4.62. Oh, this works out bang even, doesn't it? Try it. Oh, sorry, I did the answer. 60 divided by, it's 13 amps, right? That's nice. I'll take that. Kate, do I now know the current leaving the battery? Say yes. This question's going to fall apart. And then we want me to find V and I for all resistors. Well, we already answered part of this. We said, look, that's going to be 60 volts, 60 volts, and 60 volts because each one of them gets you to the bottom of the chairlift. How many amps in the left-hand resistor? How many amps in this left-hand resistor? V over R. Can't be 13 because that would leave no amps for the other resistors. Ah! How many amps in the middle resistor? How many have I used up so far? 10. I'll bet you the right-hand one has 3 amps from the 13. Is that right? Could you find the power if I asked you to? V times I. That's about a C minus C level question. Let's do a B level question. Example 8. What makes this a B level question? Look carefully. Well, there's some stuff in parallel. Yeah, but you'll also notice something's missing. What didn't they give you? Sorry? Didn't give you the battery. I don't know the height of the mountain. Okay. In fact, that's one of the things they want me to find. Find the voltage and power lost in each resistor, then find the voltage of the battery. A common mistake, look up. Kids go, oh, don't write this down. They go 1 over R parallel. That's going to be 1 over 10 plus 1 over 15 plus 1 over 20 plus 1 over 5. No, 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 no. These two are in parallel with each other. These two are in parallel with each other and can be combined. These two are in parallel with each other and can be combined. So I'm going to do these two. In fact, I'm going to do them up here because I got room. I'm going to go 1 over R parallel. That's going to be 1 over 10 plus 1 over 15. What can I replace that 10 and that 15 with as a single resistor? What do you get? I think it works out even. Or am I wrong? What'd you get? This is the same as a 6 ohm resistor. I'm going to redraw this circuit. So here's my mystery battery. I'm telling you the top is just that. Is that okay? Taya, no, yeah. What about the right hand? Okay, let's do these two. 1 over R parallel, that's going to be 1 over 20 plus 1 over 5. What can I replace that 20 and that 5 with as a single resistor? That's a 4? So you're telling me that? What about the bottom ones here? 1 over R parallel is going to be 1 over 12 plus 1 over 12. What can I replace those two with? I can do that in my head. You get 2 over 12, 6, yes? Okay. Oh, they did tell me 5 amps. Yes? I got that right from there. Ella, how many amps are going through this 6 ohm resistor? How many amps are going through this 4 ohm resistor? How many amps are going through this bottom 6 ohm resistor? Let's do that and keep going. They wanted me to find R total. Well, this 6, this 4, and this 6 are in, notice, they're in series. How do I combine resistors in series? Don't need to go 1 over. What do I just do? Add them up. Okay, so R total is 6 plus 4 plus 6. In fact, this circuit is the same as mystery battery and a 16 ohm resistor. But Ella, how many amps are going through that 16 ohm resistor? I know 2 things. How many volts are being used up in this circuit? Yeah, you're reaching for your calculators or doing it in your head. 80, is that right? Well, if I lose 80 volts over here, how high must the chairlift be? How high must the battery be? How many volts are we getting from the battery? 80. Okay, so I'll go label that in my original way up here. 80 volts. So I actually found the voltage of the battery first, even though they asked for it last. Now the voltage and power lost in each resistor. Oh, okay. Come back to you, Ella. This section here is the mathematical equivalent to this section here. How many volts did we lose in this section? Oh, how many volts did we lose in that section there? I times R. Yeah, loud and proud. What? So from here to here, say it again. How many volts? So correct me if I'm wrong. From here to here, how many volts? Look up. From here to here, how many volts? That means this hill is 30 volts and so is this hill. That's how high that section is. Hey, I know 2 things on the top. How many amps are going through that 10 ohm resistor? No, can't be 5. People, I know 2 things. 30 divided by 10. Well, how many? Yes. Oh, you know what'd be really cool? It'd be cool if there was 2 amps going through the bottom one so that the total was 5. Is there 2 amps going through that bottom resistor? When I go 30 divided by 15, do I get 2? Okay. You see why I glared at you for the 5 amps there? No, they add to 5 amps. Let's keep going, Ella. This right-hand branch, how many volts do we lose going through this right-hand branch? That means this one's 20 volts high and this one's 20 volts high. Knock, knock. I know 2 things. How many amps in this 20 ohm resistor? And then you can either say, well, the other one's got to be 4 because they add to 5. Or you could go 20 divided by 5, and lo and behold, you also still get. Oh, wow. This is fun, Mr. Dueck. The bottom one, I could cheat. Are both resistors identical? Who remembers how will the current split then? It's going to be 2.5 apiece. But if I didn't remember that, I said you didn't need that, I would say, oh, how many volts down here? So you're telling me this is 30 volts, this is 30 volts. Please tell me, if you go 30 divided by 12 on your calculator, do you get 2.5 amps? That would be wonderful if you did. It also asks for the power lost. Do me a favor, just cross that out. I can't fit it on the diagram, but could you calculate the power in any resistor that I asked you to? V times I, or I squared R, or V squared over R, and you're good. One more, we're done. Example 8, this one illustrates an important point. And the idea, the important point, Ella, is what? The equivalent resistor, the voltage drops are identical to the voltage drops in your original figure, which can really bail you out of a lot of issues along the way. Finish with this. In a household circuit, plugs and lights are wired in parallel to 120 volts. It's not direct current, it's AC, but the rules I'm teaching you will still work the same. Each circuit can only handle a certain number of amps, usually 15. It's got a circuit breaker. The circuit breaker will trip right when you get to 15 amps, or right when you go really right when you get to 15 amps. When the switch is opened, no more current will flow. So here's the question. Suppose we connect a 1500 watt hairdryer and a 500 watt TV to the same circuit. Will we cause the 15 amp breaker to trip? Now, this is AC. Do me a favor, draw a little sine wave right there. But we can treat this like DC. I'm going to do a quick little sketch here. I'm going to say I've got 120 volts. There's my source. I've got a resistor here, and I've got a resistor here. Oh! Now, AC goes back and forth, but let's pretend downhill is that way. It goes back and forth, but let's pretend downhill is that way. Here's my question, Ruby. If I start with 120 volts, how many volts must I lose going through this hairdryer? So do me a favor in your equivalent, put a little 120 volts there. What about the TV? Also 120 volts. And then they told me the power of the hairdryer. How many watts is the hairdryer? How many watts is the TV? Sorry? I know two things. How many amps is the blow dryer? Well, power equals V times I, so get the I by itself. Power divided by V. Oh, is it 10 even, I think? 10 amps there. How many amps am I using in the TV? .16, I'll call it 4.2. All right, so, Ruby, how many amps in this branch? How many amps in this branch? When they rejoin, how many amps right here? Will we blow the breaker? We're close. Plug anything else in, we're going to blow it. If you ever blow a breaker, don't just go and switch the breaker back on. It'll turn off again right away. It's supposed to. It means you set up a circuit that's requiring more than 15. In fact, I think it kicks off at 15. So 15 amps or more. Don't do that. What's your homework? You need to practice a lot of these. Sorry. 1 is good. 2 is good. 3 is good. 4 is good. You can skip number 5. Ha, 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 ha. 6 is good. You can skip 7, though. 8 is good. You can skip 9. 10 is good. 11 is good. 14 is good. 15 is good. So basically, we skipped 9, or as I like to say, what? 9? Yeah. We skipped 7. And we sort of skipped 5 because I didn't include it.